So the area of sector of a circle is the product of the ratio of the measure of the arc over 360 and the area of the circle. So we have the formula for the area of our sector, which is area of sector equals to the measurement of the arc divided by 360 times the area of the circle, which is pi r squared. Since you have your scientific calculator, I think all of you has a scientific calculator. We're going to use the exact value of pi. Okay? The exact value of pi is 3.14 3.14, 15, 92, 65, and 4. Or you can just type in your scientific calculator the sign pi. Okay? But we're going to use the exact value of pi in finding the area of our sector. So that is our formula. Even if the given in the circle is the measurement of the angle, since we have the theorem about central angle is equal to the measurement of the arc. So even though the given is the angle, the central angle of the circle, you can still use this formula in finding the area of sector, since central angle is equal to the intercepted arc of the angle that is given. For example, we have this circle. For example, we have a circle P with a radius of 15 centimeter and an intercepted arc that measures 72 degrees. So we're going to find the measurement of or the area of the sector that we have in the circle. Following the formula that we have, so area of sector is equal to the measurement of the arc divided by 360 multiplied to the area of circle, which is pi r squared. So the measurement of the arc that is given in our circle is 72 divided by 360 multiplied by pi, exact value of pi, times the radius, which is 15 centimeter squared. So we have 72 divided by 360, which is equal to 0.2, multiplied to the product of the pi and 15 squared. So pi times 15 squared is equal to 225. So get the product of all the numbers that you have in the problem. So 225 times pi times 0.2, we will be having an area of sector which is equal to 141.37 centimeter squared. So that is the area of the sector that we have in circle P, measuring a radius of 15 centimeter and an intercepted arc which measures 72 degrees. Okay, question in this example for the area of sector. Okay na, can I clear the screen with this example? Again, nagsusulat pa si Drop. Okay na. Okay, let's have another example in finding the area of sector. Okay. So for example, we have a problem. A circle has a radius of 4 inch. What is the area of sector bounded by a 45-degree minor arc? And we're going to leave the answer in terms of pi. That means, kapag sa question may nakasulat or it's being mentioned that you're not going to change the pi sign, so it will remain as pi in terms of pi. For example, here, so area of the sector is equal to the measurement of the arc over 360 multiplied to the area of circle, which is pi r squared. The measurement of the minor arc is 45 degrees divided by 360 multiplied by pi. Our radius is 4" squared. So it says here in the problem, we're not going to change the value of pi. It will remain as pi in our final answer. So 45 divided by 360 is equal to 0.13 multiplied by pi times 16. Since 4 squared is equal to 16. So 0.13 times 16 is equal to 2.08 pi. So that is the area of our sector in the circle that is given in the problem. So pag may nakalagay, leave your answer in terms of pi, walang papagpuhin kay pi. It will remain as pi in your final answer. Okay, so we have 2.08 pi as the area of sector 2.08 pi inch squared. So that's the area of our sector. Okay, in terms of pi. Okay, so let's have an example wherein the given is a radius and a central angle. Kasi in the first and in this example, the given is the minor arc or the intercepted arc. But what if the given, it's the measurement of the angle, and we're going to find the area of the sector of that given circle. So for example, we have this problem. A sprinkler on a golf course fairway is set to spray water over a distance of 70 feet and rotates through an angle of 120 degrees. Find the area of the fairway watered by sprinkle. Okay. So since the given is the angle of the sprinkler, which measures 120 degrees, and we have the measurement of the radius or the distance of the sprinkler, which is 70 feet. We have the theorem about central angle. That central angle is equal to its intercepted arc or congruent to intercepted arc. So that means kung ang measure ni central angle is 120 degrees, the intercepted arc is also 120 degrees. So even in the problem, the given is angle, we're going to use the same formula in finding the area of the sector, which is area of sector equals to the measurement of the arc divided by 360 times pi r squared. So the measurement of the arc, so if this is the arc of the circle and the measurement of the angle, the central angle measures 120. So intercepted arc is also equal to 120. Okay? It's equal to your central angle. Kung anong measure ni central angle, same ng measurement ni intercepted arc. So 120 divided by 360 multiplied by the exact value of pi with the radius, which is 70 feet squared. So 120 divide 360, which is equal to 0.33, multiplied by the exact value of pi, times 70 squared, which is equal to 4,900. So 4,900 times pi multiplied by 0.33, we have an area of sector of the circle which is equal to 5,079 feet squared. So that is the area of our sector. Do not forget the unit of measurement in writing your answer for the area of sector or area of segment. Since we're looking for the area, dapat merong unit of measurement, which is squared unit of measurement that is given in the problem. Okay, so let's question about the area of sector before we proceed with the area of segment. Okay na? For the area of sector. Sige, let's proceed to the area of segment. Okay. Area of segment is a combination of the formula of the area of sector minus the area of the triangle. So how do we find the measurement of the area of segment? We have the formula for the area of sector, which is the measurement of the arc divided by 360 multiplied by the area of circle. While the area of triangle, we have the formula, which is base times height divided by 2. So that is the formula that we are going to use to find the area of segment. So area of sector minus the area of triangle is equal to the area of the segment in the circle that we have. For example, we have this circle. Okay na? Can I clear the screen? Okay. For example, we have this circle. What is the area of the shaded region of the circle with a radius of 4 meters and without or a right angle? Central angle measures which is equal to 90 degrees. So we have the angle that we need and the radius. So following the formula for the area of segment, area so segment, area of segment is equal to the measurement of the arc divided by 360 multiplied to pi r squared minus base times height divided by 2. That is the formula that we have for the area of segment. Okay? The area of sector minus the area of a triangle. So we have the radius, which is given, which measures 4 meters, and the central angles that measures into 90 degrees. So measure of the arc, which is equal to 90, since we have a central angle that measures 90 degrees, divided by 360 multiplied by the exact value of pi times the radius, which is 4 meters squared, minus our base and the height. The base and the height is also your radius. Kapag right triangle, ang nasa circle, it's the same measurement with the radius in the given circle. So your base and your height is also 4 meter. So your base is 4 and your height is also 4 divided by 2. So we already changed all the value in the formula that we have for the area of segment. So we can now perform the operation. So 90 divided by 360, we'll be having a 0 point. So 90 divide 360, which is equal to 0 0.25, multiplied to pi times 4 meters squared, which is equal to 16, minus 4 times 4, which is equal to 16, divided by 2, which is equal to 8. So minus 8. So 0 0.25 times pi times 16 minus 8 is equal to times pi times 16 minus 8 is equal to 4.57 meter squared. So that is the area of segment. We have 4.57 meters squared for the area of segment in our circle that measures 4 meter as the radius and the central angle, which is 90 degrees. So that is for our area of segment. Let's have another example for the area of segment. Okay na? Can I clear the screen with this example? Okay. So for example, we have this circle. What is the area of the shaded segment shown at the earth? Right? Round your answer to the nearest 10. So the circle C has a radius which measures 18 inch and the central angle that measures into 60 degrees. So we're going to use the formula that we have for the area of segment. So measurement area of segment is equal to the measurement of the arc divide 360 multiplied by the area of the circle minus by the area of the triangle. So our measurement of the arc is the same measurement with our central angle, so it's equal to 60 degrees. So 60 divide 360 multiplied by pi and our radius, which is 18 inches squared, minus the base and the height of the triangle. So since the triangle is not a right triangle, we need to find the height. Kailangan hanapin muna si height of our right triangle. And this triangle is an equilateral triangle. So that means the side is also 18 inches. And we need to find what is the height of this triangle. And the formula for finding the height of the triangle, height is equal to a squared c squared minus a squared. That's the formula for the height of our triangle. C squared, or C, stands for the hypotenuse of the triangle, and A stands for one leg of the triangle. So kung 18, ang buong one leg of this triangle, since we're getting the height, you will get only the half of this side. So half of this measurement of this leg, kalahati ng leg na to is 9. So we have 9 for A. So 9 squared minus C squared is this side, the hypotenuse of the triangle. We have 18. So 18 squared. So 18 squared equals to 324 minus 9 squared, which is equal to 81. So 324 minus 81 is equal to 243. Get the square root of 243. So square root of 243 is equal to 15.59. So that is our height for the triangle that we have on the circle. So 15.59 inch is our height. So since we have already the height, we can now proceed in finding the area of segment. The base is 18 multiplied by our height, which is 15.59 divided by 2. So 60 over 360, or 60 divided by 360 is equal to 0.17 multiplied by pi multiplied by 18 squared, which is equal to 324 minus 18 times 15.59 divided by 2 is equal to 140.31. So the area of our segment, so 0.17 times pi times 324 minus 140 is equal to 33.04 inch squared. So that is the area of our segment. As you can see in the area of segment, madaming sinusolve. Kapag walang height or kapag ang triangle is not a right triangle, we need to find the height for the area of segment. But if its angle is right or 90 degrees, no need to find for the height. The height is the same measurement of your radius. Okay. Let's have another example with this kind of circle, which is not a right triangle.
Teacher,
Yes, po.
where'd you get 9? Was it?
This one.
Yeah, I didn't hear what you were saying.
We get the 9 here, half of the leg. Half of the leg side of your radius, or half of the radius. That's where we get the 9. Since hinahalf natin yung triangle to find the height. Okay pa? Okay, let's have another example. For example, we have this circle. Okay, so let's say we have circle A with a radius of 10 centimeter and a central angle that measures to 100 degrees. Let's say we have a central angle that measures 97 degrees. So that is our central angle. And we need to find the area of the segment of the circle that we have. So since our triangle is not a right triangle, we need to find the height of our triangle for us to be able to solve the area of the segment. So area of segment is equal to the measurement of the arc divided by 360 multiplied to the area of our circle minus the area of the triangle. So before we proceed in using the formula for the area of segment, we need to find the height of our triangle. Height is equal to the square root of c squared minus a squared. So if we're going to look for the height, we need to get the half of our radius. Half of radius is 5. So we have for the hypotenuse, it's equal to 10. So 10 squared minus the half of one leg of the triangle or half of the radius, which is 5. So 5 squared. Since the measurement of our radius is 10, half of the radius is 5. So 10 squared is equal to 100 minus 5 squared is equal to 25. So 100 minus 25 is equal to 75. Square root of 75, which is equal to 8.66. So that is for our height of the triangle that we will be needing in finding the area of the segment. So since we have already the height, we can now proceed in solving for the area of segment. So measurement of the arc, we have 97 degrees for the measurement of our arc. So 97 divide 360 multiplied by pi times the radius, which is 10 centimeter, squared minus the base. Base is the same with your radius. Base is the same measurement of radius. Base is equal to radius. Okay? So our radius measures 10 centimeter multiplied by the height that we have solved a while ago, which is 8.66 divided by 2. So 97 divide 360, which is equal to 0.27 times the exact value of pi times 100 minus 10 times 8.66 divided by 2 is equal to 43.3. So 0.27 times pi times 100 minus 43.3 is equal to the area of segment, which measures 41.52 centimeter squared. So that is the area of our segment. Okay, so that's how we find for the area of our segment. So try to solve for the area of the segment of this circle. Can I clear the screen with this example? Okay. Try this circle. For example, we have the circle. With a radius of 5 centimeter and a central angle which measures 90 degrees. So find the area of the segment. Kapag right triangle na, no need to find for the height, ha? If it's already right triangle. Or if the central angle measures to 90 degrees, no need to find for the height. The height is the same measurement with the radius kapag right triangle.